Good? This is the last section we're doing in chapter 4. There is another one, but we're not doing it. We already did kind of it, so. All right. Last couple things you have to remember here. All right, I'm going to put. So two more theorems you've got to remember. Base angle theorem. It's kind of easy. Don't get hung up on the wording too much, but if two sides of a triangle are congruent, so I'm going to mark these two sides as being congruent, then the angles opposite them are also congruent. So what kind of triangle is this, first of all? Isosceles. So isosceles triangles are special because if their sides are congruent, then the angles opposite are also congruent. Okay? And then this is the converse, which is basically just going the other way. It says if two angles of a triangle are congruent, then the sides opposite them are also congruent. So it's the base angle theorem and its converse.
Is this only for isosceles?
Yes. Okay? All right, so let's just use that a little bit. If HG is congruent to HK, then what can we say? Then angle G is congruent to angle K. So that's the base angle theorem. If KHG is congruent to KJH, did I do that right? KH, oh, I did it wrong. KHJ, that's this one. You see those two?
Yeah. How are they?
If they are congruent, yeah, look, it's an isosceles triangle. Look at that. If you just look at that one, they're a little off, but forgive it. So if those are congruent, then what can we say? We can say that and that are congruent. HK is congruent to JK. JK, okay, by the converse of the base angle theorem. All right. In triangle PQR, PQ is congruent to QR. Name the two congruent angles. It's very challenging today, isn't it, so far? Okay, turn it over. Corollaries. It's kind of like an attachment, sort of. Corollaries to the base angle theorem. If a triangle is equilateral, then it is also what? Equiangular. Kind of makes sense if you think about it. Okay. If a triangle is equiangular, then it is equilateral. It's like the same idea of the isosceles triangle, except you have an equilateral triangle. So the angles opposite have to be congruent. All right, is it possible for an equilateral triangle to have an angle measure other than 60 degrees?
No.
I know it's easy to answer that with just a no, but we should explain. Okay?
No, because of me.
To have equilateral, the angles must be congruent. I'm abbreviating, not proper sentences, sorry. So we have to do 180 divided by 3, don't we? If they're congruent, we have to take 180 and divide it by 3 equal parts, and that would be equal to 60 degrees. It's the only way it would work. Okay? All right. Find the measure of angle X and angle Z. So let's take a look at this. What do we know so far? We know this angle is 50 degrees. We know these sides are congruent. So we know that these are also what? Congruent. What do we know about the angles of a triangle? They add up to what? 180, which means I take 180, subtract 50 degrees, and I have 130 left over. So I have to split that in two, because there's 130 degrees left for these two. And since they're congruent, I just divide it by 2, and it's 65 degrees. 65 degrees, 65 degrees. Of course, it would be more appropriate to write this. The measure of angle x and the measure of angle z is equal to 65 degrees. That would be the appropriate way of writing it, I suppose. Find the values of x and y in the diagram, then find the measures of each angle. Wait a minute, what's wrong with these notes? There's no proofs. Find the values of x and y in the diagram, then find the measures of each angle. So, let's take a look at this. First of all, let's look at this triangle right here. Can we get x just off of that picture? What kind of triangle is it? Equiangular, so its sides are congruent, right? We were given that it's equiangular, so x has to equal 7. X has to be 7. So I'm going to mark up it right now. I know that's 7, 7, 7. I don't know if I'll need to know, but I know that's 60 degrees. No, the corollary. So, now let's look at this one right here. What do you notice about those two angles? Which means that what?
The opposites are equal.
Oh, that side is congruent to that. Wait, how long is this side?
7.
7. So 7 equals y plus 4, and y equals 3.
I actually got that.
It was too easy, wasn't it?
I was like,
That's it.